Good morning, viewers. Today we will be handling density. My name is Nicodemus Mwambela. I'm an after-school educator. And this topic is mainly suited for the Form 1s, but for the purposes of the Form 2s and upper classes, you can still just tune in and so that you revise and see how much you know in this topic. So in densities, we will go first of all by the definition, and we say that density is mass per unit area, mass per unit volume, per unit volume. That means mathematically, it can be represented like this. Density is equal to mass over volume. So now, since we are talking about mass and volume, we may need to remind ourselves what is mass and what are the units of mass, and also what is volume and what are the units of volume. So mass is a measure of quantity of matter, and units are either kilograms, or we also use grams, but now the standard units are kilograms. Then for volume is a measure of the amount of space occupied by a solid or substance. And the units for volume, you can say it is for SI units are cubic meters, but we also use cubic centimeters. Now, so when we talk about density as mass per unit volume, here we are dividing mass and the volume for you to be able to get the density. Let me just give a very easy example, simple example of how you find density. If, for instance, we take the mass of some substance to be equal to, say, 10 kilograms, and the volume of the same substance to be, let me give it in cubic meters, say 0.05 cubic meters. So what is the density? Now, we obtain density by dividing mass over volume. So that means we divide the 10 kilograms and then by 0.05 cubic meters. So when you divide that, in mathematics, you multiply denominator by 100. You also multiply the numerator by 100. So that comes to 1,000 over 5. So that comes to 200 kilograms per cubic meters. So that tells you that the units of density is kilograms per cubic meters. But now we can also have alternative units is grams per cubic centimeters, or let me write it clearly, grams per cubic centimeters. You can, for instance, take now water. Water is a good example. If, say, the mass of water is, let's say, 10 grams, and the volume of water is also 10 cubic centimeters. So again, you find the density of water by dividing the mass over the volume. So that gives us 10 grams divided by 10 cubic centimeters. So that gives us 1 gram per cubic centimeters. Now, it's important for you to be able to know how you do conversions. For instance, moving from grams per cubic centimeters to kilograms per cubic meters. How are the two of these units related? Now, if we just do, for instance, what we found earlier, the mass of some solid to be 200 kilograms per cubic meters, we can convert this one into grams per cubic centimeters, because we know that 1 kilogram, 1 kilogram is equivalent to 1,000 grams. And then we know that 1 meter is equivalent to 100 centimeters. So when you square both sides, or when you cube both sides, so you cube here and you cube here. So let me cube the whole of, including the units. So when you cube on the left-hand side, you'll have 1 cubic meter is equal to, when you cube 100, that gives you a number with 6 zeros. So 6 zeros, that will be 1 million. So that means 1 cubic meter is equivalent to 1 million cubic centimeters. Therefore, if now we want to convert 200 kilogram per cubic meters into grams per cubic centimeters, so it's just like saying 200 times now kilograms, they are how many grams? They are 1,000 grams. So you just like multiplying 1,000 grams. Then we are dividing by a cubic meter. But what is a cubic meter? A cubic meter is 1 million cubic centimeters. So now the zeros are going to cancel. 3 of these are going to cancel. 2 of these are going to cancel. So now that is giving you 2 over 10. That is the same as saying 0.2 grams per cubic centimeters. Therefore, 200 kilogram per cubic meters is equivalent to 0.2 grams per cubic centimeters. So now there is a relationship. We can see here a very clear relationship between these units and these units. And the relationship is that 1,000 kilogram per cubic meters is equivalent to 1 gram per cubic centimeters. So in fact, instead of you going through the very long way of trying to convert the units, you can just take this relationship here, so that if you are given units in kilograms per cubic meters, you can convert them quickly to grams per centimeters. So that means if you have, for instance, say 300 kilogram per cubic meters, or what is it in terms of grams per cubic centimeters? It will just going to divide by 1,000. So that gives you 0.3 grams per cubic centimeters. The density of mercury is 13,600 kilogram per cubic centimeters. What is it in terms of grams per cubic centimeters? You're going again to divide this one by 1,000, and therefore it will give you 13.6 grams per cubic centimeters. So now we've been able to look at the definition of density. We've also discussed the units of density. Then we have also discussed the conversion between the units. The official units are, SI units are kilogram per cubic meters, but now we said that grams per cubic centimeters is also very common units that are used, and therefore you should not be able to know to do conversions between them. If, for instance, you have been given in grams per cubic centimeter, say 0.4 grams per cubic centimeter, you want to convert it into kilograms per cubic meters. So if you're moving from grams per cubic centimeters to kilograms per cubic meters, you multiply by 1,000. When you multiply 0.4 by 1,000, that gives you 400 kilograms per cubic meters. So that is insofar as the density, simple densities are concerned. I also want to discuss the density of mixtures. Sometimes it's a bit rather tricky when you talk of mixtures. You have certain substances mixed together. Both of those substances have got their own unique densities. But now you are now being asked, what is the density of the mixture? I want us to consider, for instance, substances that are miscible, something like alcohol and water. The two of these can be mixed together, maybe to dilute alcohol. You can use water. So now suppose the alcohol, the mass of it, the mass of alcohol, let's talk of 30 grams. And then the volume of alcohol is, let's call it maybe 40 grams. Sorry, not grams, but 40 cubic centimeters. And then for water, we have some water, the mass of water, let's say it is 20 grams. But since the density of water is 1 gram per cubic centimeter, the volume also should be 20 cubic centimeters. Then now you mix these values. So when you mix them, you'll find that the mass of mixture is going to be the sum of the masses of the two substances. So that means the 30 grams of alcohol and the 40 grams of water. So that means 30 grams plus 40 grams giving us, sorry, it is the 30 plus 20 grams, not 40 grams. 40 was the volume of alcohol. So 30 grams plus 20 grams. What does that give us? It gives us 50 grams. So that means the mass of the mixture is 50 grams. And then there's also the volume of the mixture. Here we assume that in mixing the two substances, there is no change of volume. So the volumes therefore must be volume of mixture is going to be the volume of water, which is 20 cubic centimeters, plus the volume of alcohol, which is 40 cubic centimeters. Now, when you add the two, you're going to get 60 cubic centimeters. So now how do you therefore find the density of the mixture? Officially, the density of mixture is found to be mass of mixture divided by volume of mixture. So that means you're going to divide the mass of the mixture, which is 50 grams, divided by the volume of mixture, which is 60 grams, 60 cubic centimeters. Sorry, making that silly mistake. Now, of course, you can simplify as 5/6 grams per cubic centimeters. Or if you want, you can decimalize, you can express it as a decimal. I'm sure it will be 0 point something grams per cubic centimeters. So that is how you are able to handle density of the mixture. Sometimes you may be given some values, maybe some values are missing and you are required to find some missing values. So I want to give some tricky question now so that you may be able to see how you can use the same formula to be able to find what is missing in a particular question. Let me phrase the question this way. Problem. An alloy. An alloy is a mixture of metals. When you mix two metals like brass, it's a mixture of iron and something, lead, I think. So when you have a mixture of two metals, we call it an alloy. So an alloy has a mass of, say, 20 or 200 grams, and it comprises of metal A of density 6 grams per cubic centimeters and mass 80 grams, and metal B of mass 120 grams and density. And density, the first one had density and mass, and this one also has got mass and density. Let me change this density to say, let me talk of volume. And volume, let me give this one volume, say what? Say 40 cubic centimeters. Now, from here, find the density of the alloy. So this is a tricky question that you may need to be extremely careful, because you may need, first of all, to list down the values for metal A.